recording this. All right, everybody. Oh, wait, I'm sharing the wrong thing, I think. Let me go back. All right, bear with me, guys. Bear with me. Here we go. This should be the correct one. All right, you know your teacher is not high-techy, right? So have patience. All right, so this is notes 1.3. This is transformational functions. This is the one we do right after that investigation, 1.3. So now that you know all of that, this should be a breeze. It should be a piece of cake, and we should be able to go through it really quick. Just make sure that you are practicing these things because they're not easy to get if you don't continue to practice. So persistence is the key. You got to continue to practice. We already know that the parent function is the simplest form in a set of functions that forms a family. And as soon as we throw in the A, H, and K, that's going to cause the graph to have some effects on it. And it'll either flip or reflect, it'll slide, it'll turn, it'll dilate, it'll get wider or narrower. It can shift vertically, horizontally, or both. So we know these things to be transformations and translations. And these are the same words from Algebra 1 that you learned. So we're going to jump right into it today. We are just going to graph or practice graphing the parent graph for each of the functions that we looked at. So the line, the v or the absolute value, and the parabola or the quadratic function. And we'll just practice doing transformations or creating transformations on the graph. So the first one we're going to do, example 1, is going to be f of x equals x. This is your parent graph for a line. So this is a linear function. The parent is f of x equals x. We already know that. Think of that a, h, and k are rounded as the slope-intercept form. So really, with a line, we don't have a shift that's left or right, because if we were to plug in a number here and then distribute the slope to simplify the equation, we pretty much end up with mx plus b. So the number that you see attached in the back of a linear equation, that's always going to be your k value. So that one to me is one of the easiest ones. So we know the parent graph is going to, hold on 1 second, let me get this ready. All right, so we know the parent graph is going to go through 0, 0, 1, 1, negative 1, negative 1. And this is why it's called the identity function. So it looks like this, right? As soon as we start, it may be a little off, but you know what I mean. As soon as we start moving things around or putting numbers in front, behind, or in the equation somewhere, is going to create some changes. So f of x equals x plus 1, think of it as the same exact equation because the k is 1 that has been moved up 1. Think about that, or graph it as you graph slope-intercept form. Graph your y-intercept, which is going to be your k value, so that's at 1. And then remember your a value for linear equations is basically your slope. If you don't see a coefficient for x, then your slope is 1, and that's positive. So it's 1 over 1, rise over 1 over 1, and 1 over 1 to the other side. So this is your new one. So these should be a piece of cake. This is the same parent graph. So for C, you have the same parent graph that has been moved down 2. This is your y-intercept. So graph it at a y-intercept of negative 2. And then your slope is 1. So it's the same thing. Your a value gives you your slope, and your slope has not changed. So it's still 1. So that's your new line. Pretend it's straight, because I'm doing this without a ruler. But on your paper, you should be able to do it, a little more, let's say, designy than mine. So you have f of x equals 2x. So this one's different. All of these were k values because they were at the back of the equation. So for a line, k value and y-intercept is the same thing. This one doesn't have a y-intercept. This one has an a of 2. So it's basically the same equation as the parent graph, but it'll be a little narrower. It's tilted up. The slope is bigger. So you graph at 0, 0, right? Since you don't have a y-intercept, the y-intercept is 0. You have a slope of 2, which is the same as 2 over 1. So it's 2 up, 1 to the right, or you can go 2 down and 1 to the left, because a negative over a negative is still going to give you a positive slope. And this is what that line looks like. There we go. So that's the transformations for the family of linear functions that happens to be a line for your parent graph f of x equals x. So now we're moving down to quadratic functions. This is your parabola. These are the ones that have the quadratic or the square. So this is f of x equals x squared. That's your parent. As soon as you plug in that a, h, and k, that equation has changes around it. So that means the graph is going to be affected. And this, by the way, this format for the quadratic is called the vertex form, because if you pull the H and the K, you have your vertex. So for the parent graph, remember that this one, and disregard these little points or dots on the paper. I think that's from when I copied the document. So disregard these little points. But you have the parent graph that goes through 0, 0, 1, 1, negative 1, 1, and 2, 4, and negative 2, 4. Remember, this is your U shape, your parabola, right? So there's your parent graph. So the shape of the graph will not change. What's going to change is where it is located on the grid. So this one right here, f of x equals x squared plus 1. That plus 1, that's a k value of 1. Your h value, since you don't see it, is 0. So that automatically gives you your vertex. Your vertex is going to be 0, 1. Remember, any symmetrical graph will have a vertex. So 0, 1 is your new vertex, so that's here. And because the k is 1, obviously that causes your graph to move 1 unit up. Now, because your a value is 1, right? You don't see a coefficient for your x squared, then that a value is 1. The width stays the same. The width is not affected. So 1 over 1, and then 3 over 1. And I'll show you, once we do the unit on parabolas, I'll show you the trick for when you get ready to graph. There's a pattern that goes with the slopes, yes, plural, slopes of a parabola, the curve. So I'll show you that later on. So you get to see, and you have x squared minus 2. This is also a k value because it's outside of x. So you have an a value of 1. So in front of x squared, you have nothing, so that's a 1. You have an h value of 0 because you don't have anything stuck with x. There's no value stuck inside with x. And you have a k value of negative 2. I'll put it down here. I run out of room on these things, so I write too big. But anyway, your vertex then is 0, negative 2. And that's where you put your new vertex, 0, negative 2. That makes sense because your parent graph is supposed to start here. But because you have a k of negative 2, that means you're moving the graph down 2 units. An a value of 1 doesn't change the width. So the width is 1, 1, and then 3, 1, 3 over 1. So that's your graph. Now, when we get to D, f of x equals x plus 1 squared. My a is still 1. Haven't changed that. There's no value here. Now, this value, that's your h value. That's stuck inside with x in the parentheses. So that's an h value. And be very careful because remember, this is supposed to be a negative. So the only way that we could have ended up with x plus 1 is if you had x minus a negative 1. So your h is a negative 1. The true value of h is negative 1. You don't have a number out here, so your k is 0. And that gives us a vertex of negative 1, 0. It's always going to be h, k. Just be careful with that h value. So instead of at 0, 0, your new vertex is at negative 1, 0. So on the left, negative 1, 0 makes sense because your h value being negative will shift your graph to the left. And the width is still the same. So 1 over 1 from there. And if you want to count from that new point, it will be 3 over 1. And that's pretty much the pattern with the slope, which I'll elaborate later on. So the width does not change. Think of the same width as the parent graph. All right, moving on to E through H, this is still parabola. So all of these are the same shape. These are all U shape. So x minus 2 squared. There's no a value, so a is 1. Remember, if you don't see a coefficient, your coefficient is 1. Your k value, your h value is inside stuck with parentheses. And be careful, remember this is x minus the number 2. So this is just 2. And the k, you don't see it, there's no k value, that's 0. That means your vertex is at 2, 0. So this, because your h is positive, right? When you pull it out, remember this is x minus whatever your h value is, which happens to be a positive. Pull it out, that's a positive. So 2, 0, that is going to shift your graph to the right. So 2, 0 is here. Width is still the same, so it's 1 over 1 over, and then 3 over 1 over for the next point, or points. It's symmetrical, so whenever you find a point on either side, you can reflect that to the other side. So then we move over to this one. No a value, so we haven't really touched on a yet. Eventually we will. Your H value, remember, right here, that's the tricky one. If you see X plus, that came from X minus a -3, a double negative. So your H value is really -3. Your K value does not change, so your K is 2. That means your vertex for this one actually shifted down and, left and up. So this is -3, 2. So it's shifted 1, 2, 3, 1, 2, right here. So that's where your new vertex is. And your A is 1, so the width is still the same. And I'm gonna run out of the grid here, so I'm just gonna approximate. It's gonna go around there. It's not perfect, but it's there. And so then G, you have an A value of 1. And remember, you can rewind or pause. Oh my God, that looks horrible. This whenever you want and come back to it and review it again. And it does take practice, guys. You're not gonna get it the first day, it takes practice. Your H value in here, careful, it's X minus a +3. So H is +3 and K is -1. Your new vertex will be H comma K, so 3, -1. See how we're flying through these because we did the investigation first. So 3 to the right, 1 down, that's what that means. So 3 to the right, 1 down. Width is still the same, so 1, 1, and then 3, 1. And then this is what you have right here. There we go. So now we get to H. H is the one that looks different because notice there's no value inside with H with there's no H. There's no value inside with X. I can talk today. And there's no value outside. That automatically gives you an H of 0 and a K of 0, right? The number you do have is on the outside of X. That's your A value. So your A value is 2. So that means that every single Y value is affected by a multiplication by 2 on this one. So you have your vertex of 0, 0, right? You can use that A value as a slope, but you can only use it one time. You're going to use it as a slope from the vertex only one time. So you're going to go up 2, 1 to the right, and you can reflect that to the other side. So up 2, 1 to the left. Now to find another point, I'm going to let you do this one with 3 points. Usually we want 5 when we're sketching. But to find another point, we're going to do something else that I'm going to teach you later. So for now, if it looks like that, if your A value is greater, do it with 3 points, or you can plug in a value. So for example, if I wanted to plug in 2, and I plug in 2 here, I'm evaluating the function for an input of 2. 2 squared is 4 times 2 is 8. So at 2 on the X, this graph will be up here, somewhere up here at 8. So you can always do a table, but I'll show you a shortcut for when we get in depth with parabolas. All right, so I think that's it for the parabola. So now we move on to absolute value functions. Remember the parent graph is f of x equals absolute value of x, and is at 0, 0, 1, 1, -1, 1, and so on and so forth, right? It is symmetrical, and it has a vertex because of that reason, because it's symmetrical. So that's your parent graph, your absolute value of x. Now, absolute value of x plus 1, the 1 in this case is at the back. It's detached from x, so this is your k value. Now, if you don't see an h value in here, that h value is 0. Because your h value is 0, then your vertex for this one is at 0, 1. So this is a graph with the same exact shape. It has not been, it's not narrow, it's not wide, because your a value is still 1. If you want to jot that down, you can. So you're graphing it 1 unit up. So instead of a 0, 0, a 0, 1, where your new vertex is. The width is still the same. So it's 1, 1, 1, 1 on the other side, all symmetrical, and that's your new V. Then you have absolute value of x minus 2. So again, your A should be here. You don't see it. That's a coefficient of 1. So A is 1. H should be stuck with x. In here, you don't see it. So that H is 0. K is the number outside, and that K doesn't change sign, so that's -2. So this one has a vertex at 0, -2, which means that it's going down 2 units. So 0, -2, but the width is still the same. So 1, 1, 1, 1, and you graph. So when we graph, by hand when we sketch these things, we want 5 points at least. If you want it more, you can always do more, but you can do it through pattern or you can do it through evaluating the function, plugging in values of x and seeing what you get for the y. Now this one here, f of x equals absolute value of x plus 1. My a value is still not there. And by the way, I forgot to mention this, but you do have the format up here. So you can follow where a, h, and k should be and decide what values they are based on where they are. So a value, it should be in front of x. I don't have one. That's 1. The h value should be inside. But be careful with that one because that one is negative, right? Remember, it negates that negative, negates that sign. And then the k value, I don't have one, so that's 0. That means my vertex on this one is -1, 0. So this one is moved to the left 1. -1, 0. There's no difference in the width, so the width is still the same. And remember, V is made out of 2 lines that are straight lines. So with V, you can actually use the A value as a slope as many times as you want. You can do this one with the parabola because the parabola is not a straight line, it's a curve. So I'll show you the trick for that one eventually. Or the pattern, I should say. It's not a trick, it's a pattern. So this one right here, f of x equals absolute value of x minus 2. No a value, so a is 1. You have a number inside with x, that's your h value, and that's the one that's going to negate the sign. So that's a positive 2. Your k, you don't have one, so that's 0. That means the vertex for this one is at 2, 0, right? H, k. So that one is actually 2 to the right. So right 2, but nothing up or down. It's not moving up or down because your k is 0. And then the width doesn't change because your a is still 1. You have to remember, you have to memorize what each of the values is going to do to your graph and where they are located. So a value should be here. That's 1. So a is 1 on this one. You don't have it, so it's 1. H, be careful, stuck inside, but that's going to change sign. So that's -1. K is outside and K does not change. What you see is what you get. So it's 1. So that means the vertex on this one is a -1, 1. So 1 left, 1 up right here. It's not reflected. The A value is not there, so it's not affecting the width. So you have basically the same exact width as the parent graph, which is 1 unit over and 1 unit up every time. So they're lines. So every time you can use that same slope or that same A value. So this one here, same thing. The A value is 1. The H value stuck inside, negative sign. Remember the opposite sign. K is what you see, is what you get, and that's outside. My vertex on this one is -1, -2. That means my vertex is 1 left, 2 down. They're both negative. There's no width change, so the width is the same. And there's no negative. The A value is not negative, so there's no reflection on this either. And we'll look at those eventually. So when we get to this one, to D, you have x minus 3 in absolute value plus 2. So still no A value. So your A value is 1. Your K, remember, careful, that's this one right here. Sorry, your H value. Oh, good Lord. Let me change that. I jumped the gun here, guys. Sorry. Let me see. So H, not K. H is the one stuck inside with X, and that's the one that's going to change sign. K does not change. So that's 2. So that means your vertex here is 3, 2. So 3 units to the right, 2 units up from 0, 0. That's your new vertex. So 3 to the right, 2 up. So you're right here. But your width didn't change. And it's not reflected, but because my A value, my equation is not negative. My A value is not negative. So this is the graph. There we go. So that's your V's. That's your absolute value. So we've talked about up, down, left, and right. And we talked a little bit with the parabola about an A value of 2 or a stretch. So reflections or flips are going to either flip the graph vertically, and that's a reflection in the y-axis. That's where your x values are going to change signs. If you were doing a table, you would see the x values change sign. When you reflect a graph in the x-axis, which is horizontally, these are the ones that we're going to do the most. The y values change the sign, which makes sense because if you have a V that opens up, your x values are the same. They stay the same, where y values are positive. If you flip it over, your x values are still the same. where your y values are now negative. So it makes sense that your y values will change when you reflect over the x-axis. So for a function f of x, the reflection in the y-axis is inside with x. For a function f of x, the reflection in the x-axis is outside of x, so it's the a value. And remember, this is the one that we're really going to focus on. So let's look at this right here. So you have the equation f of x equals 3x plus 3. You have the same equation in both. This one is asking you to reflect it in the y. This is asking you to reflect it in the x. So the first thing we're going to do is just graph the equation. And this is just a line, 3x plus 3. This is mx plus b. So I'm going to plot a 3 for the y-intercept, and it's a slope of 3. If I can go up 3 and 1 to the right, I can go 3 down and 1 to the left. So that's a negative over a negative, and that still gives you a positive slope. So that's my graph. And I'm going to do the same thing here since it's the same line, right? We're working with the same equation. I'm going to plot a 3. That's my y-intercept. And then I have a slope of 3 over 1. That's the same as negative 3 over negative 1. So negative 3 over negative 1. So I have the original. So here's the original. Now, this one is telling me to reflect it in the y-axis. That means your x values are going to change, are going to flip, right? You're going to change your x values or change the sign of your x values. So if I have a point here, right, negative 1 comma 0, that negative 1 will change to positive 1. So it'll be right here. And this one would be 0 comma 3. Well, that one I can't change it because it's right on the x, is 0 on the x. So it's going to be 0 comma 3 is still 0 comma 3, 0 on the x. So now your new graph reflected in the y-axis will look like this. Sorry, guys. I am not using a ruler for this, so it looks horrible, but you get the idea. So this is a flip where you took the graph and flipped it vertically. So that means your x values changed. When you flip it horizontally, your y values are going to change. So if you have a point here, right, negative 1 comma 0, that one's not going to change. But you have a point here, 0 comma 3, that's going to go to negative 3. So that's going to be down here. And you have this point here, which is negative 2 comma negative 3. You're going to change the y, the sign for the y value. So it's going to be negative 2 positive 3. So it'll be up here. So this is what it looks like when you reflect it horizontally. And that's the one that we're going to do the most. So not over the y, over the x. And notice that they do look different. So keep an eye on that. So a vertical stretch is going to multiply all your y values of a function by the same factor greater than 1. So when a is greater than 1, you have a stretch. That's all that means. And it affects your y values. When you have a compression, you have a value of a that's between 0 and 1. And that's going to reduce all of your y values by the same factor. Right? And we have reached the end of that one. Nope, not really. So let's finish up this one. This one's a little longer, so bear with me. So transformation of functions on here, we're just going to practice the stretching and compressing. So for the first two, these are parabolas. For the last two, these are absolute values. So these are v's. So this one right here, we kind of did this one already up there, but your a value is 2, right? So think of your parent graph. Oh my God, that looks horrible. Think of your parent graph, the points that your parent graph goes through, right? So 0, 0, 1, 1, negative 1, comma 1, right? A stretch by 2 is going to multiply all of your y values by 2, by that factor. So if you multiply 0 by 2, you get 0. If you multiply 1 by 2, you get 2. And if you multiply, again, 1 by 2, you get 2. So now your new points, instead of being the same place as the parent graph, are multiplied by 2 for the y. So 0, comma 0, 1, comma 2, negative 1, comma 2. So 0, comma 0, 1, comma 2, negative 1, comma 2. Remember that on the table for the parent graph, your next point would be 2, comma 4, correct? But that 4 will be multiplied by 2, so that will give you 8. So at 2, I know we don't have enough space, but so that you understand where it's coming from. At 2, you will be at 8 up here. And at negative 2, same thing, you will be at 8 up here. So this one here, same thing, is going to affect your y values. Think of the table for the parent graph again. That table for the parent graph is 0, comma 0, 1, comma 1, and negative 1, comma 1, right? This a value of half, or 0.5, right, will affect each of the y values by 0.5. So it's multiplication by 0.5. So it'll be 0, 0. 1 times 0.5 is 0.5. And again, 1 times 0.5 is 0.5. So instead of 0, 0, 1, 1, negative 1, 1, you're at 0, 0, 1, 0.5, negative 1, 0.5. So it's going to make that graph widen up. So it's going to make it wider than the parent graph. And if you wanted to plug in, for example, 2, 4 and negative 2, 4, right? That's the parent graph. 4 times 0.5 is 2. And again, 4 times 0.5 is 2. So every single y value changes. The x stays the same. So 2, 2 and negative 2, 2. So I will be here and here. So anytime we want extra values, we can always either think of the parent graph and multiply the a value by the y coordinates, or you can plug in a value and evaluate and see what you get back. So input, output. So then this one, the same thing. This one, careful, because you have that +1. This one didn't have an H or a K. And I forgot to mention that, but notice that because we didn't have an H or a K for either of these, the vertex stayed the same. It's a 0, 0. Here is going to change a little bit because now you have a K of 1 on this one. You don't have anything here. So let's go through this one by one because I think I'm getting ahead of myself. The A value is 3, right? So because the A value is 3, the Y values from the parent graph will be multiplied by 3. Your H value will be here. You don't have one. So H is 0 and your K is 1. So the vertex will be 0, 1, and that doesn't change, right? So 0, 1 puts you here. There's no reflection here. Now, because an absolute value is formed by two straight lines, so, or you can say a straight line that bends, right? And it's the same, it's symmetrical on both sides, then you can use that 3 as a slope. So from that point, I can actually use 1, 2, 3 over 1, and then 1, 2, 3 over 1 to the other side. So there's many ways of graphing these things. You don't always have to relay on a table. A table is more for when you have curves, right? Graphs that are curves. When you have straight lines, you can always think of your A value as your slope. So this one here, notice that this got a lot narrower than the actual parent graph. Parent graph will go through 1, 1, 1, 1. So it will be a unit of width over a unit of width. So it'll be wider. This one is going to make your graph wider than the parent graph. So there's no H and no K. So if H is 0 and K is 0, then your vertex doesn't get affected. Your vertex is still a 0, 0. I don't know what I'm writing anymore. So vertex is a 0, 0, right? But you have an A value of half. So you can think of, for example, the parent table. Parent table would be 0, 0, 1, 1, negative 1, 1, right? Multiply each of your y values by 0.5. So this is 0, 0.5, 0.5. Or you can think of this as a slope of 0.5 over 1. So for every one whole unit you move on the x, you're only moving half a unit on the y. So either way, you're going to end up on the same points on the graph. So 1, 0.5 puts you here, and you continue to do 1 over 0.5, and it puts you there. Same thing to the other side because it's symmetrical. There's no reflection here. So this is here and here. And if you ever have any doubts, calculate or evaluate with an input-output. Plug in a number, pull the absolute value, multiply by half, and that gives you your output. All right, for these, we've already practiced some of these already when we did the investigation. So I'm going to kind of go quickly through these. For problems 1 through 4, given the parent function and the description, write the new equation. So for this is absolute value. So we're going to have absolute value bars around the x. Vertical shift down 5, that's your k. Minus 5, horizontal shift right 3, h is 3. So this one becomes f of x equals x minus 3, right, in absolute value, minus 5. H in here, that's left and right. K in here, out here, that's up or down. Linear, vertical shift up 5. So linear equation, f of x equals x. Vertical shift, up or down, up 5, that's a y-intercept of 5. So that's your equation. Quadratic, that's going to have x squared. Horizontal shift left 8. Horizontal is left and right. Left 8 is an h value of -8. When you plug in, that negative will change it to positive. So be careful when you write it. So f of x equals x plus 8 squared. We don't have a shift that's up or down, so there's no k. Quadratic with a vertex at -5, -2. Well, we already know that the vertex is made up of h and k. So they're giving us everything we need to write the equation. So f of x equals, and by the way, this is quadratic, so it's going to have a square. So remember h being -5, when you plug it in, that equation is x minus -5. That makes it a positive. So x plus 5 squared, and then minus 2 because the k doesn't change. Absolute value, translated 3 units to the right, that's an h value. 1 unit up, that's your k value. Remember the h value? That's the one that's tricky, right? So you have absolute value, so f of x equals x, because it's 3 units to the right, that's a positive 3. So it's x minus a positive 3, x minus a positive 3. And then 1 unit up is your k value, that doesn't change, so it's plus 1. Quadratic again, so squared. Translated 3 units left, that's an h value. 2 units up, that's your k value. So if you need to label these things, this is h, this is k. H will move your graph left and right. K will move your graph up or down. So f of x, and remember that it's quadratic, right? X, 3 units left is a -3. So you're writing the equation x minus a -3. That's a plus 3. Squared, because it's quadratic. And then 2 units up is plus 2. And the last one here, quadratic, vertical compression factor of half. That's your a value. This is an a value. A reflection along the x-axis, that's a negative. So f of x equals, there's a negative for the a. The a is 1/2. And I don't have an h or a k here. So all I have to do is write the x squared because it is quadratic. That should be a 2, guys. It's just out of the page. Let me see if I can fix it so that I don't confuse you. Let's try that again. So x, I'm going to try to make a little tiny 2. Oh my God, it's horrible. There we go. That's the best I can do, so you got to take it. All right, so that's when you're given information in a sentence, basically, and think of translating that sentence into math or into an equation. Whew, we're almost there. This one's long, guys. All right, so here, for problems 1 through 3, write the equation of each graph. So very, very simple. Let's start with the middle one because the middle one is a line. Y equals mx plus b. So you need your y-intercept and you need your slope. Your slope on this one is basically 1, 2. So you have 2 units for rise, 1 unit for run. And remember, it's rise over run. The equation is positive because the line is going up from left to right. So what's the equation? F of x, mx plus b, your slope first, which is 2. So 2x plus 1. That's your equation for that one. For the v and the parabola, what you need is your a and your vertex. So your a value and your vertex. Remember, your vertex is basically h and k. That's all you need to write the equation, a, h, and k. Your vertex here is -2. Sorry, I'm reading that backwards. 3, -2. So your vertex is 3, -2. That's right here. 3, -2. You have to notice that the V opens up, so there's no reflection here. There's no negative A. A is going to be positive. And because these are lines, you're going to count your slope 2 units over 1 to get to the next point on the graph. So 2 over 1 is a -2. So now you have all the info you need. You have the shape, which is a V. You know that's going to be absolute value, right? Your h value is +3, so it's x minus +3. And then your k value is -2, and that doesn't change. So that's your equation. Ah, I missed the 2. The a value of 2, remember that's in front of x, so that should be in the front. Even it happens even to me, so you have to pay attention to what you're doing. So then this last one here, this one's easy to write because your a value, you're going to see it in a second, your a value is 1. Let me see if I can make this a little bigger so you see it better, because it's kind of small. So it's worth to do this because I want you to actually see the the points. So right here, same thing. You want your vertex, right? And you want your A value. So let's see. Your vertex is at -1, 567, -1, 7, right? Remember, this is H and this is K. Your A value on this one. So the A value is defined as the slope 1 unit away from the vertex. And it's defined that way because the slope right here is not going to be the same slope as the slope here, because this curves. If it was a line like, you know, a regular equation of a line or a V, they're straight lines, that would be the same slope everywhere. But right here, this slope right here is different than this slope right here. So the only thing you can do is use the slope one time from the vertex. So for every unit that you move either to the left or to the right, for that unit, you're moving 1 unit down. So that point is right here. So think of counting from this point to the next point where you hit the graph, right? That's 1/1, but it's going down. So your A value, your absolute value is 1 for the width. So the width is the same, but for graphing or for the slope from the vertex is -1 because it opens down. So you have f of x, and by the way, it's a parabola, so you got to use squared when you write the equation, equals negative, we don't need the 1. You're going to have x minus h in here. So x minus -1, that's x plus 1, and then +7 outside. That's your k value. All right, let me bring it back down so that we can look at the last two. This one's a little longer, guys, but I think this is the last example. So explain in writing how each function is related to the parent function. So that's basically what translations are happening. What is happening to the graph based on A, H, and K. Graph both the parent and the transformation function on the same grid. This is absolute value. This is a parabola. Remember, this is a V shape. This is a U shape. So let's start with this one. First thing you notice, obviously, absolute value. Let me actually go back and make this bigger again, because it's easier for you to see it. So absolute value, we have an A value of -1 because we have a negative right there. We have, so there's no change in the width because the absolute value of -1 is 1. That doesn't give me a change in the width. That gives me a reflection that's horizontal over the x-axis. Then you have x plus 2. So you have an H value of -2. Remember, that's the one that changes. This came from x minus -2. That's why H is -2. And your k is outside and that doesn't change. So k is 1. Your vertex then is -2, 1. So 2 left and 1 up. So 2 left, 1 up. So I'm right here. Now, my slope is 1, right? This is a straight line. So I can think of it as slope, but it's down, not up. So a slope of -1 is a slope of -1/1. So for each unit that you move left or right, you're moving 1 unit down. And because this is symmetrical, you're basically doing the same thing on both sides. And again, excuse my graphs, they're not the best. So I'm doing them freehand. There's no ruler involved here. And remember, anytime you need to pause this, or if I kind of go quick because I want to keep these under 30 minutes, 30 to 35, I always go over a little bit, but you can always pause it and go back. So this one right here, because of the square, I know that it's a U shape. My A value would be here. I don't have it, so A is 1. I know that the width is the same because the absolute value of 1 is 1, and an A of 1 doesn't change the width of the parabola. I also know that there's no reflection because that A is positive. Then I have an H value stuck with X. Remember, X minus +1. So that's actually a +1. And then you have a K value of 2 that does not change, K of 2. That means your vertex is a 1, 2. So to the right and up. So to the right one, up 2 units, it will open up. And then because the A is 1, it's the same width as the parent graph. So it's 1/1. And then the next one will be 3/1, which I'll show you that trick. So when an A value in a parabola is 1, you can think of that A value as a slope, but there's a pattern. It's a slope of 1/1. Think of it as a slope. 1/1, 3/1, 5/1, and it continues to do that forever. That's just a pattern of parabolas. That's only when your A is 1. So instead of having to create a table or do evaluation where you plug in input output to see what you get for the y coordinate, you can just use that slope continuously from the previous point. So for example, 1/1 from the vertex is 1 up, 1 to the right. From that new point, I can use 3 up, 1 to the right. And if I wanted another point, from that point, I could go 5 up and 1 to the right. That's the pattern. If your A is not 1, then you would have to multiply the top, which is your slope always over 1, by that number. So that gets a little more complicated. So for now, just know that if your A is 1, you can always use this pattern. And because I just need 5 points, because you're graphing these things by hand, you're sketching by hand, we just need 0, 0. We need not 0, 0, but whatever your vertex is. So you need the vertex. You need another point, and that's given by 1 over 1. And then from there, another point, and that's given by 3 over 1. Once you have those 2 points, you just reflect to the other side. So you don't even need to use the 5 over 1. All right, guys, and we have finally reached the end. Have a great day. I'll see you on the next one.